Today we're starting section 7.4, properties of logarithms. We're going to use properties to simplify logarithmic expressions, and we're also going to translate between logarithms and any base. Okay, remember previous lesson you guys calculated pH using this equation. pH equals negative log of your hydrogen concentration. Okay, that can also be expressed as 10 to negative pH equals hydrogen concentration. Okay, because logarithms are also exponents, you can derive the properties of logarithms from the properties of exponents. So we're going to review a few properties of exponents and apply them to the properties of logarithms. Okay, remember with exponents, to multiply powers with the same base, you add the exponents. You have the same base, which is the b. Okay, when you're multiplying them, you add the exponents. Okay, just like with logarithms. The logarithm of a product, which is multiplication, is equal to the sum of the logarithms of its factors. Okay, I have log base 3 of 1,000. That's equal to log base 3 of 10 times 100. 10 times 100 is 1,000. So log base 3 of 10 plus log base 3 of 100. Okay, these are equal. If I have the same base, if you're adding logarithms, it's the same as multiplying them. Here's an example with algebra. Log base b of mn is the same as log base b of m plus log base b of n. It's useful to simplify logarithms. Okay, the property in the previous slide can be used in reverse to write a sum of logarithms, which are exponents, as a single logarithm, which can also be simplified. And we're going to do this in the next example. But basically, if I have log to the base b of m plus log to the base b of n, that's the same as log to the base b of m times n. Oops. Scratch that. Sorry. M times n, which for real problems we'll be able to simplify. But let's try one. Okay, first one. Express log base 6 of 4 plus log base 6 of 9 as a single logarithm, then simplify. So if we have addition with the same base, that means that we multiply. Okay, which is log to the base 6 of 36. Now to simplify, we take that mental math. 6 to the what power equals 36. 2. Let's try another one. Express as a single logarithm. Simplify if possible. I have the same base, so that means I do log to the base 5. 625 times 25. Okay, handy dandy calculator will tell you 625 times 25 is 15,625. Okay, use some mental math. My mental math is not that good of a calculator, so I'm going to pull out my calculator. 5 to the what power is 15,625. Believe it or not, 5 to the 6th power is your answer. Okay, why don't you guys try this one? Go ahead and push pause. Okay, you didn't want to do it because it was a fraction, but it really wasn't too bad. Alright, moving on. Remember to divide powers with the same base, you subtract the exponents. I'm dividing with the same base b, so I take m minus n. Because logarithms are exponents, subtracting logarithms with the same base is the same as finding the logarithms of the quotient with that base. Okay, that's why logarithms and exponents are those inverses. Okay, I have the same base. Base 5, 16 over 2. That's my division. That's the same as log base 5 of 16 minus log base 5 of 2. Same here, log base b of m over n, same as log base b of m minus log base b of n. We're actually going, from this way over, if that makes sense. We're starting with these problems and moving that way. The property can also be used in reverse. And as a reminder, just as exponents cannot be simplified if they don't have the same base, logarithms must have the same base. So let's express this as a single logarithm and simplify if possible. So I get log, I have the same base, 5, and because it's subtraction, I can divide, which simplifies to log base 5 of 25. Now we're going to use that mental math skill, and we get 5 to the what power equals 25. Your answer is 2. Okay, why don't you guys try this one? I know it's just one example and then one you try, but you got it. There you go. That's all we have for today. Part 2 will go over some more properties.